workbook now. We will be making that available at a future date. That still needs to be worked out on the platform and security to access that. So I'll be reaching out to you at a future date with that information when it becomes available. Please do, there was some confusion over the sign in and what I've been asking for with regards to that. I just ask that you sign into the chat because you can change the name on your screen and want to make sure whoever registered is actually in attendance, both at the beginning of the course, and I'm asking you to do the same at the end of the day. So before you log off of the meeting at the end of the day, please just sign in to let me know that you are here again. I'm into the chat. I will save that chat and use that for my registration, for my checklist for who was in attendance. I believe those are the only items that I have at this time. If you have any questions, feel free to reach out to me through the chat. I've also included my email on my username. So if you need to get in touch with me directly, you can also get my email through there as well. With that, I'll hand it over to Andreas. Thank you.
Good morning again, everybody. One note too, just make sure you keep yourself muted, and we are gonna do the same thing again today with some times for some Q&A. I think where we can open up and hopefully have some dialogue. And so anyways, we'll try to keep it as active as possible. So I think just quickly, just to recap kind of what we covered yesterday. So yesterday we really drilled into the fundamentals of the manual. We went through the unified sizing criteria. We went through, I guess to back up first, when the manual applies was the first section. Then we got into the unified sizing criteria, and then we looked at the pre-treatment structural BMPs or STPs, and then the primary structural STPs, and we looked at non-structural STPs and got into the soils testing methods, requirements a little bit. We're going to actually revisit that in some more detail today as part of the exercise. And so you'll see that again. And so I think the goal of today is really just to take the fundamental things that we went through yesterday, which is kind of the basis of the manual, and then try to work towards applying those. And so we're going to start with this hands-on exercise, which is really geared towards understanding how to implement some of these things. And then we're going to look at kind of the ongoing permit compliance. So when you actually get your permit and the site's permitted, then what happens? And how do we keep these systems functioning in the long term? And also keep the state happy in terms of reporting back to them on the operation and maintenance issues. Planning and designing for existing sites. I'm going to go through that, and then we're going to end with some future changes and updates. And so one of the things we're going to look at in some more detail, I know we had some good discussion yesterday about the 3-acre rule. We have a couple more slides on that and some opportunity to have some more discussion about that. Some more questions. I'm not sure if Wynn is going to jump on this morning or not. But if somebody from Stormwater program does jump on, we can have some more dialogue with them about that. And then covering some of the research initiatives specifically related to bioretention and gravel wetlands, and related to the soil specifications, some of the design specifications that are in the manual for those structures. So that's where we're headed. So regarding the exercise, I think we're going to do our best to keep this as simple as possible, but saying up front, it's complicated. And I think the goal of today is really just to familiarize people with the project sheets and to understand the workflows. There's going to be a lot of entries on these which are not going to be totally intuitive to begin with, but I think the goal is really just to understand how they fit together and how to go from one to the next and where the information is that you need to populate on the worksheets. So there's this classroom exercise for the Utopia development. Sounds like a wonderful place. Looking at soils in in some great detail, working with contractors and MS4s. And so this is what I was saying in terms of the workflow. Really, I think the most important thing with these workbooks and worksheets is to understand the process to going from one to the next to the next. And I think the state has done a good job making these worksheets and workbooks as user-friendly and as, I don't know, cookie cutter is the right word, but really just kind of plug and chug as they can, with good instructions and good direction in terms of what you're supposed to fill out and what's supposed to auto-calculate. And the whole idea here is, you know, it's the intention, I think, is just to make it easier for everybody. And I can see Wynn is actually on, so which is great if there's any other questions that come up for him. So this is really how we're going to look at this. The first thing we're going to really look into in some detail is the Stp Selection Matrix workbook. And the exercise, we're going to do it in the context of this exercise. And so the exercise is this development, and it's a hypothetical proposed residential and commercial development. And it has 33.4 acres of total site area. And the proposed impervious area within that 33.4 acres is 12.9 acres. And the soils on the site are a mix of hydrologic A and B soils. And so in your resource packet that we provided ahead of time, there's going to be a series of site handouts. So I'm just going to share this quickly and show you, this is what that zip file should have looked like. And there is a PDF at the bottom, VSMM classroom handouts. If you open that, there should be 11 or 12 PDF pages in there. So that correlates to these. And so you should keep these handy because we'll need these at specific times during the exercise to actually pull information off these. So I think what I want to do right now is just go through each one of these handouts and just explain what's on here so people can understand what these represent. So handout 1 is the site plan. This is our site plan. So our proposed site is a gas station here. We have a little residential subdivision here and then a commercial development here, and it's all connected by these new roads. We have a stream coming down here, we have a stream flowing across here, and then we have a stream flowing here. So when we look at this site on the A&R Atlas, and I assume most, if not all, people are now familiar with the Atlas, but if not, it's a really critical tool in all of this. Going to the A&R Atlas, pulling up the soils information. So you can see right here, we have the soils, hydrologic soil groups checked. And we have the map soil types right here. And so one thing to note, just as we're looking at this, a good a side note, some of these are mapped as A/D and C/D. Reason being is that they could be a good soil type, good meaning sand, you know, favorable soil type in the instance of this A/D, but the groundwater is persistently high. And so it's A/D because at times of the year it could be A when that sand is exposed, but most of the time it's saturated. And so my understanding is DEC is comfortable with the concept of just applying this as a D when you have an A/D. If there's anything new on that, Wynn, jump out, but that was my understanding.
Yeah, that's still our general take on that, just because you know, you have to do the pre-post comparison, and if you treat it as an A soil and in fact you can't infiltrate due to the high groundwater, you know, we feel it's fair to treat it more like a D soil in terms of the modeling and standards compliance.
Great.
Just a background on why we have these particular dual call-outs. It's that the original intent of this information was developed for the agricultural community. So they could make decisions on whether to underdrain or to tile their lands. And if they did, then they could convert something that is a high groundwater regime into something that would be more growable area. So anyways, that's the background when you're seeing these particular types of things. If you underdrain it, then the opportunities to take advantage of the characteristics in the top 1 foot, 2 feet, 3 feet, depending on where your subdrainage is what's trying to be explained in those particular slashed out areas.
Nice. That's interesting. I didn't know that. Okay, so the third handout is essentially just the first two overlaid on top of each other. So we have the site plan, and then we have the hydrologic soil group A soils up on the upper site. So the residential area is underlain with A. And then we have B down here with the gas station and the commercial development over here. Streams, still have the streams on either side here. And then handout 4, we're adding in drainage areas. So these blue drainage areas are the entire drainage area going down to a discharge point, which is the point at which the runoff actually enters the receiving water, and that's indicated as these yellow points. And one note on defining the site area. The site area, the state gives you an opportunity to either define the site area as the total disturbed pervious plus impervious area, or the total drainage area. And so I think that's at the designer's discretion. So I think in this case, we're defining it as the drainage area. So each one of these blue areas has an acreage associated with it, and we're defining that as the site area. And the discharge points, labeled as these numbers 001, 002, 003. I don't think that the agency says specifically it has to be numbered, but there has to be some unique identifier for each discharge point, because that comes into play on pretty much all these worksheets. And so it's important to define that specific discharge point. And then handout 5 actually has these two test pits. Okay, so these yellow test pit areas, test pit 1 and test pit 2. And that's going to correlate to a couple additional handouts where we actually have that soils information. And so we're going to get to that in a minute. Here we go. So this is test pit 1. Okay, so this is up here in the A soil. It's part of the residential site. We had a test pit. And we talked about seasonal high groundwater yesterday. And I think we mentioned redox or redoxamorphic features modeling. That's really the key information. I mean, other than the characterizing the soil type, it's the key information is really whether or not there's presence of redox, because redox is indicative of a seasonal high groundwater table. And so if we're looking at this test pit log, and this is our own format, this can be formatted any particular way. I don't think DEC has a specific format requirement. We have depth, the soil type, some descriptions and notes, soil moisture, soil color, and then a photo. And in the description right here, you can see the key information is no redox features, okay? So this is from 0 to 8 inches, no redox features. 8 to 20 inches, no redox features. 20 to 60 inches, no redox features. So down to the bottom of the pit, there's, based on this test pit, there's no evidence of any seasonal high groundwater. So when we look at test pit 2, which is down on the commercial site, we're looking at this again. And so from 0 to 15, we're recording some redox features. And we're recording redox features at 15 to 27 as well. So, and then down to the bottom. So there's seasonal high groundwater evidence throughout the whole section. So handout 8 is infiltration testing at TP1. So remember, that's the test pit that was done in the A soils for the residential site. And this is actually a report from our Johnson permeameter. You know, these reports will vary depending on the type of practice that you use. But essentially, if you're looking at this, we're introducing water into the soil, and the infiltration rate, as time elapses, the infiltration rate is steadying here along a line. And that's basically what you want to see. Is you want to, with this type of a test, you want to see that it kind of levels out and that you're achieving kind of a constant infiltration rate. And that's supposed to be indicative of when you actually have a stormwater system in place. Essentially, you're just balancing out, because right away you're going to be getting pretty high infiltration, and then it's going to flatline at some areas. So that's really what we're looking for. And so I think the key takeaway information on this worksheet is right here. So this is in, I'm sorry, inches per hour right here, 2.28 inches per hour. Okay, that was the measured infiltration rate right there. So in order to do step one of the exercise, we're going to look at the worksheets which are in your resource training materials. And just to go through that, you have these two PDFs, and then there's these two folders. So one is to complete and one is completed. So the completed are obviously the ones that are answered, right? So we want to go through first and go into the complete. And within that, you're going to have two free spreadsheets. You're going to have the master STP matrix, and then you're going to have the site standards workbook. The first thing, exercise step one, is going to be to complete the master STP matrix. So that's this one right here. So for one of the discharge points, I'm just going to go through that, and we'll look at that together so we can see how this looks and what the information is that's required on here. So I think when you open this up, if everybody has this opened, the first thing that you're going to see, there's several tabs on the bottom. 4 tabs. First tab is going to be, actually, there's more than 4 tabs. There's a preface. So you can see there's a preface. There's a really good written summary that the state has in terms of what is a tier 1 practice, tier 2 practice, tier 3 practice. Excuse me. And then moving over, there's a flow chart. The flow chart is to help you guide whether or not you're going to be using a tier 1, tier 2, or tier 3 practice. And then there's going to be a tab for each discharge point. You can see with our example, we have SN001, SN002, and SN003. So if you have a site with 5 discharge points, you're just going to create another tab. And you're going to do this evaluation for each discharge point. So if we look at discharge point 001, if we just go through this one together, this is for, remember, the gas station 001. So we're looking at the gas station, and step 1 is the water quality treatment standard entirely managed with one or more of the following tier 1 practices? And it's going to ask us, it's going to say yes or no. And the thing is, we're not actually going to know until we go through the checklist on the bottom, because even though this is the first question, we're going to go through the feasibility analysis to really understand, excuse me, if a tier 1 practice is doable on this site. So what we need to do is actually go to step 2. And under step 2, we have, right here, we have all of these tier 1 practices. Okay, these are in blue. And we have practice availability for water quality treatment. And you can see right now it says all yes. So these will actually change depending on your answers to the feasibility restriction questions below. Okay, so there's a number of these feasibility questions. During this exercise, you're not going to have all the information to answer all these questions. So what I've done, just to make it easier, just to get a feel for it, is the questions that you could potentially answer with the handouts, the information that we have is highlighted in yellow, okay? So for this particular, for discharge point 1, we can go down and we can say, you know, will runoff to the practice include discharge from a hotspot land use or activity? As we were discussing yesterday, a gas station is a hotspot land use. And so we're going to have to answer yes to that question. So you can see when I changed it to yes, this changes and these change right here. Okay, so no tier 1 practices are available for use. Proceed to step 3 to evaluate tier 2 practices. So now we can go up and we can confirm no. We can't manage our water quality entirely within a tier 1 practice because of this restriction, okay? Hopefully that makes sense. So then we would continue down and we would have to go through the next feasibility assessment that we went through yesterday to figure out whether or not a tier 2 practice is doable or whether we need to go to a tier 3. So if we go all the way down to the bottom, step 3, other feasibility constraints for remaining tier 1 and tier 2. So the question is the water quality treatment standard entirely managed within tier 2? And if we select yes, stop, no further justification is needed. This worksheet is done. If we select no, the state is asking us to provide written specific justification below, right here. And so this is where we talked about utilities, we talked about impacts to Act 250, local zoning, archaeological issues, several feasibility issues that are listed out in the manual, and I think they're also actually listed out right in this preface. With respect to whether or not you can use a tier 2 or whether you need to provide written justification in the state that, hey, we have to go to a tier 3. So that's how that works. And so we have within that spreadsheet, the 2 complete spreadsheet, there is a tab for discharge point 2, the residential subdivision, and then discharge point 3. And so why don't we take, let's see, it's 8:55 right now. Let's take until 9:10, so 15 minutes, I think, to go through discharge point 2 and discharge point 3 on your own. And then we'll reconnect at 9:10 and walk through the answers for those, okay? And just some of the things to consider on this, you know, consider conditions for each discharge point and how they differ: soils, hazardous materials, groundwater conditions, and then note which tier practices are available for each discharge. All right, hopefully everybody's wrapping up relatively soon. Never sure if that was too much time or not enough time. I'll just wait one more minute here and then we'll we'll start reviewing it together. All right, so back online here, looking at the results of the first part of the exercise, the STP Selection Matrix. So this is the slide we have up right now. So this is for the discharge point that we went through together, Discharge Point 1, which is the gas station. What BMPs should say STPs are an option. Tier 1 or Tier 2. So I think we discussed Tier 2 because Tier 1 is prohibited because it's a hotspot land use. So that one was pretty straightforward. We just answered that. Really just needed to answer that one question. All of the cells grayed out. We knew we had to go to Tier 2. So, you know, just to keep in mind, we're assuming Tier 2, but you know, there's now would need to be some site-specific feasibility questions on this site. Is a Tier 2 really feasible? We're assuming it is, so we're going to stop there. We're going to say if a Tier 2 is doable, and we're going to go on from there. Okay, so that's Discharge Point 1. So for Discharge Point 2, which was the residential subdivision, what STPs are an option? Tier 1 or Tier 2? Came up with Tier 1. The reason being that there was no restrictions on infiltrating practice, right? So in order to figure that out, we looked at the soils, and the soils were the key right here, no redox features, right from the top. No redox. No redox. We're in an A soil. So as you go through, there should be no restrictions on utilizing a Tier 1 practice for that site. For that discharge point, I should say. And then for 3, so the commercial development, we're looking at Tier 1 or Tier 2. So the way it should have worked out is that you had Tier 1 for disconnection only. Tier 2, if favorable feasibility analysis indicated that a Tier 2 was feasible, and then a Tier 3 if there was no, you know, if it was an unfavorable feasibility analysis, it would have to go down to a Tier 3. So we can look at that one together. So this is for 3, Discharge Point 3. Again, we started at step 2. We answer these questions. Do the soils have an infiltration rate of less than 0.2 inches per hour? No. We're assuming that. But the key question here are highlighted in yellow. Will runoff to the practice include discharge from a hotspot land use? No. So that basically greens out all these boxes here. And the key questions are on the bottom here. Bottom of practice would be below seasonal high groundwater table. Seasonal high groundwater table or bedrock would be less than 1 foot from the bottom of the practice, and seasonal high groundwater table or bedrock would be less than 3 feet from the bottom of the practice. So I answered yes to all these, okay? So the reason I answered yes to all these is because when you look at the test pit for that site, which is Testbit 2, okay, so we're on Testbit 2. We look and we're seeing redox features right at the surface, all the way down. And so by filling this out in this way, we're making the assumption that infiltration is not going to be feasible because of the restrictions on the seasonal high groundwater table. Now, in reality, there's an option to engineer this site so that potentially you could infiltrate, and that would potentially mean filling the site so that you could actually get above that table. But this worksheet, just for the terms, in terms of just practicing this, we're assuming that the practice is going into the native material. We're going to have restrictions with the groundwater. And so the interesting thing in this is that the simple disconnection and the disconnection to filter strips or vegetated buffer are still green. And so that indicates that there is still the possibility of doing some disconnection on the surface, either in the form of the simple disconnection or the disconnection to filter strips or vegetated buffers. So that's why in the answer, we're saying tier 1 for disconnection only, because that is potentially still an option, right? So question for you on that, do you know if that was an intentionally constructed that way so that even if there was restrictions on the seasonal high groundwater, DEC is still asking people to evaluate disconnection? Is that?
Yeah, exactly. Because it's even in an A soil with a seasonally high groundwater table, may for much of the year have a pretty good infiltration rate, and therefore it would remain available as a practice. Is the reasoning there?
Okay. One question that came up, which would be interesting to look at, seeing from Hugo, I see in the spreadsheet that sites management section would provide a letter regarding infiltration in contaminated areas. To my knowledge, this is not a calculation or assessment conducted by the SMS, so we don't provide a letter. So if we look at where that is, I'm trying to see, let's see where that is specifically, actually. Hugo, if you're unmuted, maybe you could just guide me to that.
Yeah, it's row 19 on the spreadsheet.
Oh, got you, right here. Mm-hmm.
I think it's a very important thing to consider infiltration in those areas. All I'm saying is that in the 20 years that I worked at hazardous waste, we don't provide that type of letter because we're not doing a calculation to see whether the plume is going to be shifted over by infiltration. It is we provide the information of what has been investigated. It's up to the designer to determine if the plume is going to be moved.
Got you. Great. Well, that's good information. Is there any other discussion on the first step, just doing that STP matrix? Was that relatively straightforward for folks? See one other question coming through. So if, for the residential subdivision STP analysis for infiltration, with the test bit being only 60 inches, does that limit the base of the infiltration practice to 24 inches without a deeper test pit? And the answer I think is yes. I think that we would need to verify at least a minimum of 3 feet below the bottom of the practice that there's no evidence of seasonal high groundwater. So if we were to go deeper, we would need to advance that test bit deeper to get verification that we're not seeing a seasonal high groundwater deeper, so that we can ensure we have a minimum of 3 feet. And I didn't get into this, but in some cases, if you're actually infiltrating more than the water quality storm, remember that's the 1 inch. If you're infiltrating the the channel protection storm just over 2 inches or anything higher, you actually need to have 4 feet of separation, and or provide the DEC with a groundwater mounding analysis. And there's a procedure in the manual to the hand tush method, I think, is referenced to provide a groundwater mounding analysis. Okay.
Andres, David
Yeah.
White here. I was frankly confused looking at Discharge Point 3 once it reached the conclusion in the matrix that although disconnect was available, that it probably wouldn't fully treat. I didn't understand in step 3 how to reach the conclusion whether or not water quality treatment standard could be entirely managed with tier 2 practices.
Right. So I think that was really, there was no specific information in the exercise to allow you to be able to evaluate whether you would have to go to a tier 3. The point I was trying to make is just that basically the spreadsheet got you to the point landed on the fact that you're going to be doing tier 2, but also you still have this obligation to evaluate disconnection for tier 1. But you would still be looking at things like the river corridor or floodplain issues or other constraints to land on the tier 2 or to make the case that you would have to go to a tier 3. So, but there's nothing in the exercise that would show you that.
Okay, thank you. I'm just hoping I wasn't missing something.
No, yeah, thanks for pointing that out. So I put this next section in as it's a few slides on the Hydrocad modeling, because Hydrocad's the most popular modeling tool which is used. And so just to give people a flavor of the Hydrocad modeling, and basically we've gone through the exercise of doing a mock Hydrocad model just for Discharge Point 1, which is the gas station. And it's really just in the context of being able to evaluate the 10-year and the 100-year pre-post development peak discharges. So just remember from yesterday, we have for the 10-year, it's the QP10 standard, and that requires you to make an evaluation of pre-development and post-development peak discharge for the 10-year storm. And then if you are over 10 acres of impervious surface, you're going to be looking at needing to meet the 100-year storm, which is an analysis of the pre-development and post-development peak discharge for that. So I've gone through, even though this is a smaller site, well, actually, no, in fact, total in aggregate, it would require the 100 years. So we've gone through and done the 10 and 100 year mock analysis for using Hydrocad. And then we can see how we extract the information from the model, and we can see at the end where we plug that into the standards and compliance workbook, okay? So I think the first thing to note in the Hydrocad is to always take advantage of the templates. And so templates meaning, you can you can customize your project, and instead of having to build that each time you set up a model, it's nice just to have a series of templates that you have stored, which already have the rainfall information in, and things like this grid, things like that. There's ways to customize the reporting so that when you also PDF the reports and send them to WIN, it has labeling and such on the headers of the page describing what storm it is, et cetera. So you can set that all up ahead of time and then just keep a template so you don't have to recreate that each time. So setting it up the first time, this is just going through, starting to look up in the upper left. For anybody that has actually ever used Hydrocad, the first step is typically in this calculation setting, which is this calculator button right here. So if we click on the calculator button, we're going to pop a window, and we're going to be able to go into our rainfall tab. And when we go into the rainfall tab, we're going to come down here, and we're going to see that we're going to have a rainfall depth to enter. And we have this nice button right here, which is this import events button right here, okay? So when we click on the import events button, we then are able to pull up the Atlas 14 table right in here. And you can see it's kind of overlapped by this final window, but there's the county right here. We have Vermont selected. So we have all the counties in Vermont. We have Chittenden County right here. We're looking at the type 2 storm. And so here are all of our rainfall depths right here. So we have the 1 year, the 2 year, the 5 year, the 10 year, the 100, or sorry, the 25, the 50, and the 100. And so by clicking OK, we basically pulled this right into our Hydrocad. For our water quality storm, which again is 1 inch in 24 hours, we're going to have to manually enter that. And so we can enter the depth of 1 inch right here. We can save it as a water quality volume storm. We can click save, so we can have that as a custom rainfall event in our model, so that we can also run the water quality storm. So after we get our rainfall all set up, we're going to be looking to build our existing conditions model. Okay, so this is for the gas station. And so within this gas station, the green area right here represents that drainage area. So remember, we looked at the drainage area in blue, okay, the site area. So that's site in its existing condition is 3 acres, and it's a woods in good condition, which is and it's underlain by hydrologic soil group B. So putting that information in, Hydrocad's giving us this curve number, which is the curve number which is representative of that land use, woods good and a B soil. We're putting in a time of concentration in here, and I'm not really going to get into the method for developing the time of concentration, but there's a couple different ways to enter it. We can enter it by direct entry. The state now requires a lag method, which is a different method than the historical method of calculating a sheet flow, shallow concentrated flow, pipe flow segments. And that's actually pretty important, because that method is a much simpler method. And I think in some cases we've figured out, especially where there's large pipe connection networks, we figured out that it's really it's over-representing the time of concentration. Essentially, it's producing very long times of concentrations, when in reality it may be a much more rapid time of concentration. If your water is getting into a pipe and getting delivered to the outlet more quickly by pipe, the lag tends to overshoot that. So something to note. Something to note, I think maybe like a project-specific thing to note that you might want to bring up with a reviewer if you have a large development with a lot of pipes. And for those that don't know what a time of concentration is, basically just the time that it's going to take for the water to move from the most hydrologically distant point down to the outlet. So the longer the time of concentration, the lower the peak discharge, because we have more time that it's taking for the water to move through the system. So once we have our existing conditions model built, we would then produce a proposed conditions model. And in the proposed conditions model, we're going to put in the proposed land uses, which is going to include the impervious surface. And that is now in this new node here that we have, proposed land use, okay? And then we're going to connect that into our triangle, which is representative of the treatment practice. And so for this site, remember we ruled out the opportunity to do infiltration because it's a hot spot. So we're going to select a treatment wetland. Specifically, it's going to be a gravel wetland. And we're going to do the worksheet for that gravel wetland next. But for now, we're just going to build this into the Hydrocad. And we're going to build in basically the dimensions and the volume, the side slopes of that bowl, of that catchment area. And we're going to put that into the Hydrocad. And we're going to define some outlets. However the outlet structure is from that structure, we're going to define as well. And once we get that all set, and obviously there's a lot of steps in between that we're just running over, as part of the design process, really refining that structure, grading it in, making it all work engineering wise. But once we have that all dialed in, we're going to be able to run our model. And so when we run the model, we're going to be able to look at our pre-development and our post-development flows. But specifically, we're going to be able to look at our pre-development, which is on the left. And in the post-development condition, we're going to have our pre-routed and then post-routed. Remember, we discussed that yesterday in terms of the waivers with the channel protection. So in the pre-development condition, it's pretty simple. We have this is our hydrograph, and time here is on the x-axis, and we have flow in cubic feet per second on the y-axis. And so as that storm passes through, this is the 10-year storm, you can see right here, we have a 3.17 inches right here. Our runoff area is 3 acres. Our runoff is really ramping up to a peak of 0.35 CFS, okay? In the post-development condition, the hydrograph looks a lot busier, right? And the reason being is that we have now, if we look here in the corner, we have our inflow, which is in green, and then we have our outflow, which is in gray, and then we have primary and secondary. So essentially what primary and secondary is it's just two pathways that the water can leave the basin, which we've defined as these outlet points. And those should sum up to the gray. So the gray is the total outflow. And the reason that the gray and the blue are the same is because there's no outflow in the red. So all you have is 0 plus 0.1 is going to be equal to 0.1, okay? So the 5.9 is representative of the fact that after the development is put in place, we have an increase in peak discharge pretty dramatically from 0.35 to 5.19. And then after that runoff is passed through our wetland, we're knocking that peak discharge down to 0.1. So really the numbers that we want to compare are going to be the 0.35 to the 0.1. So we're actually reducing our 10-year discharge from 0.35 to 0.1. So now this is for the 100-year storm. It's going to be a very similar situation, except the numbers are going to be higher, right? So we have our inflow at 3.6 and in our outflow discharge at 10.15. And with the basin in place, the gravel wetland, we're going to be knocking it down to 3.51. And you can see here, now there is a red hydrograph and then there's also a blue. So what that's representative of is the blue is the primary outlet, which is really the outlet where a lot of the water from the wetland is going to pass. It's kind of low down in the system. And then the red is actually the emergency spillway. So that's the water that's actually flooding out over the emergency spillway. So when we add up 3.36 plus the blue discharge, our total discharge out is going to be 3.51. So we want to compare the 3.6 to the 3.51. So with both of these storms, our gravel wetland is adequately sized to meet the 10-year overbank flood protection standard and the 100-year extreme flood protection standard. And so these discharge numbers are going to be reported back into the standards and compliance workbook, which is going to be the last step of the exercise which we're going to do. Okay. So the next step of the exercise is going to be working on the actual worksheets. And so we've done the STP matrix to figure out what STPs are available, tier 1, tier 2, or 3. And so now we're going to size the treatment practices that we have available to us. Okay, so I think we would go through again discharge point 1, the treatment wetland, and then you guys can work through discharge points 0, 2 and 0, 3 on your own. There are, for discharge point 1, within your folders, you're going to see a worksheet, and actually I can just bring this up. So to complete, so the first thing that we're going to do is we're going to go through this. And I realize in some people's folder, there may be 2 spreadsheets in here. Use the new one, okay? The DEC had updated it, and I think there was, the older one was still in there, just some people's. For the next 2, you're going to see if you go into the residential subdivision folder, you're going to see these 3. So you're going to have a disconnection, you're going to have an infiltration, and you're going to have a reforested worksheet. And in the commercial development, you're going to have a disconnection and the filter worksheet to do. And again, with all these, just to open one of these up, it's going to have areas in yellow are the areas that are either going to be, you're going to need to pay attention to and actually fill in the information. The areas in green are going to be what's going to be calculated, and that we're going to use the numbers that come up in those boxes, we're going to take and we're going to plug those into the standards and compliance workbook, which is the last and final step in the exercise, which is step 3. That's next, okay? So when you go down through, you're going to see a lot of the toggles will be selected mostly, and there'll be information that's put in there, but there will be some yellow areas where you will actually need to enter information. And so that information is going to be taken from one of the slides, which I'm going to bring up here next. So handout 9 gives you the data needs for completing the worksheets, okay? And so we're going to go through discharge point 1 together first. So for discharge point 1, the treatment wetland, we have 3 acres total drainage area and 1.53 impervious area. So for that, our total area is going to be entered as 3. And our new impervious area is going to be entered as 1.5. And so the worksheet is going to calculate a water quality volume of 0.1250, okay? And the DEC says right here, enter this value on the standards and compliance workbook. So we're going to go through that as the next step where that's entered. And as we work down through this worksheet, there's going to be some information in here which is already filled in terms of the volume of the practice, okay? So that would be, typically that would be information which would be learned as part of the design process, which we're not going to do today. So that's why that's filled in. So the objective would be to go through utilizing handout 9, go through discharge point 2, simple disconnection worksheet, the reforestation worksheet, and the infiltration basin worksheet. And then for discharge point 3, the simple disconnection worksheet and the filter worksheet. And then we'll regroup and run through those together, and then we'll be able to do the final step of the exercise, which is actually taking the information which we're going to be generating on these and plugging them into the final standards and compliance workbook. So it's 9:38. I don't know if the time was adequate last time. I'm thinking maybe 10 o'clock, 20 minutes. So I think we should regroup at 10. And
Andres,
I think
oops, sorry.
Go.
I just saw a comment come in from Scott Hamshaw, just mentioning how there is some discrepancy between the county-wide Atlas 14 numbers versus the site-specific Atlas 14 numbers.
Yeah.
And when we review, we do look at the site-specific numbers. You know, we reference those to make sure that's what's plugged into the modeling and the worksheets.
Okay.
I don't know if I wasn't aware that they had those county numbers already built into
Right.
maybe the newer version of Hydrocad.
Mhm.
You know, and it may be that in some instances they're so close that we haven't noticed, but you know, there are, especially when you get into the Green Mountains, there can be some big discrepancies in different parts of a single county.
Okay, yeah, so that's good. That's good information to have. So basically, what we would need to do, yesterday. I presented there was the website with the NOAA Atlas 14 where you can do it's a web-based point type of web interactive system. So we could actually get that point specific information and then put that into Hydrocad rather than just relying on the county tables, which are in Hydrocad already. Yeah. All right, great. So you guys work on those and we'll regroup at 10 and then run through the answers. Okay, we're getting ready here. Hopefully you guys have gotten to take a crack at this or finished it at this point. So just about a minute, we'll regroup and start reviewing. All right, this is Andres again. So we'll pick back up here and take a look at our results from the worksheets. And we went through Discharge Point 1, the gas station, together. And so we'll quickly look through 2 and 3 and run through these worksheets. So the first one I'm going to pull up here is the disconnection. So we should be looking at Discharge Point 2, and we're looking at the disconnection worksheet here. So if you look at handout 9 is showing you that there's basically for the disconnection, we have a total of 18 acres, excuse me, of area disconnected. And the amount of impervious within that 18 acres is 3 acres. So maybe that's the rooftop. So putting in the numbers right here, lines 1 and 2 in yellow. And then, of course, if you were doing this, having to go through all these feasibility questions about slopes, proximity to buildings, et cetera, making sure that you have all that. And then also just to note, referencing the attachment location. So where that is, attachment 1, 2, 3, if there's a specific sheet, you know, this just makes the review easier. So shows up again here in line 20. If we have the disconnected areas greater than 10 feet and for downspouts, we need to again enter the amount of impervious acreage, which is disconnected. And then we need to enter the 1 year, 24-hour storm event depth. And I didn't specifically mention that, but there's the handout 10, which hopefully you found, where it actually references the 1 year, 24-hour storm event depth. So that's where that information would be placed right there. So with that information, we're going to get a TV. So remember, the TV is this overall volume that we need to manage, right? So the TV is the 0.5150. So that's essentially how much TV benefit we're getting by implementing this disconnection. So we're going to need to save this number and return to it later. Okay, so that's for the initial worksheet, the infiltration. We have 18 acres, total drainage area, 5 acres of impervious area draining into our infiltration. So we're going to get a 0.45 value right here. And you can see right there, TV value to enter on the standards and compliance workbook for this practice. So this is the number that we're going to want right here. And we're going to plug this into the standards and compliance workbook, which is our 3rd workbook. Okay. And then the final worksheet for that one is the reforestation worksheet. So looking at the reforestation, answering all these feasibility questions, noting the attachment. So the key information in here is the excluding the impervious surfaces. So we have a total of 3 acres to be reforested. So we're getting a treatment volume of 0.013. So this is, again, information that we're going to need for the final step of the exercise. Moving on to looking at the discharge point 3, we have a disconnection worksheet for that one. We have 3 acres total drainage area. 2.5 acres is disconnected with simple disconnection. So here's our benefit right here, 0.2. We need to re-enter this right here, 2.5. This worksheet, it grays out right here, but essentially what that is the, again, that 1 year rainfall depth, okay? So this is our bottom line number right here, 0.2083. Enter this value on the standards and compliance worksheet. So this is the number that we want. So the final one, filter. We have 12.4 acres drainage area. The new impervious is 6.4 acres. We're going to get a water quality volume of 0.5317. If we continue down, this information was plugged in. This is just all of the specs about the filter bed design, geometry. And essentially what this final calculation provides us is there's a little bit of extra benefit that's being provided by the under drain. And so we're getting a bottom line value of 0.0826. And so that's actually the information. There's 2 bits of information on this sheet. We have a treatment volume of 0.0826 and we have a water quality volume of 0.5317. So there's actually 2 bits of information that's going to have to come off of this worksheet and go into the standards and compliance worksheet. I'm going to have to show you that on the 3rd step when we get into the 3rd part of the exercise. Okay, so those are all the worksheets. Amanda had a question. Can you review a basic piece of the spreadsheet, the nuance between for permit coverage and permit coverage? I've read the definition, but an example would help. So I think you mean here. And it gets a little complicated, but essentially sometimes you can have a situation where you might have existing impervious area draining into a practice, which you don't necessarily need to manage for the permit requirement, but you're including it in the sizing and the calculations to rough out the the volumes of the practices. And so you would have that information in here, and it basically gets calculated separately so that it's included in the calculation, but it's not specifically being included for credit because it's not for permit coverage. I don't know if you're still on, if you had anything else you might say about that, but that's why there's 2 different blocks.
Yeah, and also just to make sure, sometimes I know when you have the actual Excel sheet open, like you can see on your presentation, the one is for permit coverage and the other is not for permit coverage. Mm-hmm. When you have the actual Excel sheet open, for some reason it cuts off the not for portion of the not for permit coverage in the second,
Okay.
which leads to confusion. If you click on the red box, the red arrow at the top right corner, I think it clarifies it's not for permit coverage. I'm not sure why it cuts off the not for permit coverage part of that on some of these Excel sheets. But that's,
Yes.
I think, what Amanda's confusion was coming from.
Gotcha, because it says, right. I understand. Yep. Okay, she's got it. Cool.
Can I ask one more question?
Yeah, of course.
I'll just state it versus trying to type it out. If you looked at the handout 9, the data needs for BMP worksheets, and we're looking at those, can you explain? So I noticed obviously how the acres of the drainage area versus impervious area, how those, I guess, correlate. Because like for the residential subdivision, you know, it's like 3 acres of impervious we're going to be doing for disconnect, but then for the infiltration basin, it's 5 acres. So is that 3 acres from the disconnect also a part of that 5 acres, or like what's the total impervious area on that site?
Right. Yeah, that would be included. I think it's the total is 5. So that's nested within. So you basically would have your simple disconnection for 3 acres, and then that would the infiltration basin would be collecting and managing the whole site. So it's 18 acres and the 5 acres of impervious, but only 3 of that would be disconnected. So yeah, it was kind of intentionally done this way because it, you know, you have a lot of situations like this where you don't necessarily, you're not disconnecting, you know, the entire site. You might just have a fraction of it which is disconnected, and same with the reforestation. You only have 3 acres of that total 18 acres, and so it's just a fraction. So the total for the discharge point 2 is 5. Does that make sense?
Yeah, thanks. I just wanted to make sure that was like nested based on, so the same for the commercial, the disconnect is kind of nested as a part of the
Correct.
larger thing.
Correct. You got it. Yep. Okay. Let's go. So should have mentioned this too. This was just a little handy worksheet. I'm not sure anybody found it, but just to basically help track your work. So we're down in part 3 right now. We're going to get into part 3. So we're basically going to take the information which we've learned really in part 2, and we're going to plug it into a final workbook. And so what I'm thinking for the rest of the schedule for the rest of the class, if we can just get through doing this last worksheet, then we're going to be done with the exercise. And then we can take 10 just to take a quick break, and then that will be get us to probably about 11 o'clock, and then we'll basically just finish up with a couple more slides related to kind of the operation and maintenance and emerging research issues, and also just a few more slides on the soil conditions. So if that works, we'll go ahead and do that. So the final step is the standards and compliance workbook. I think we're going to do the same thing where we're just going to go through. I'm going to open up the workbook now. We'll go through the first discharge point together just to get familiarized with the layout of this. And we have handout 12 is going to give you the information that's needed for the standards and compliance workbook, in addition to the worksheets that you just generated with the TV and the water quality volume numbers. So you're going to need those, and then you're going to need this information, which is here on handout 12, okay? So looking over this is really the main body of how compliance is demonstrated. So there's a series of tabs on the bottom. You have the instructions. So there's really good instructions on how to fill this out. The blue boxes are entries that you need to make. The yellow boxes are actually optional. And then the gray boxes are calculated values. And it describes how here you have a workbook tabs, you have a summary tab, and then you have individual discharge point tabs again. So again, like the STP matrix worksheet that we started with, you have a tab for each discharge point. And then the summary tab essentially calculates everything for you at the end, okay? So you have, summary tab is really mostly auto-calculated, aside from areas where you can enter notes, okay? So if we look at this for discharge point 1, the information that we would need to put in, and a lot of this information is going to be put in for you already, but some of it you're going to need to fill out. So essentially we have the discharge point right here, the name of the receiving water, the latitude, longitude. So here's information that on yours, the to complete, you're going to need to fill out. So here's actually a link to that Atlas 14 right here. You can also use the table, which is included as handout 10. And so the information is organized. There's a pre-development area right here, drainage information, and then there's a post-development. And we have the land uses. So these are hydrologic soil groups again, A, B, C, D. And then there's grass, meadow, woods, or impervious. And there's existing impervious. And then if there's any, in the existing condition, when we get down to the proposed, we have the same land uses, but then we also have new impervious, okay? So this is where we're gonna put in our new impervious. So for the gas station, we have woods. We have 3 acres of woods, right? And it's a B soil. And I realize now that handout 12 is not in the package. I can see that point. So what I'm going to do is I'll just leave it up. I'll leave mine up on the screen when you guys do your exercise so you can see that information that you need right here. Sorry about that. So what we're going to have is in the pre-development condition, 3 acres of woods. Okay, so it's going to calculate, it will automatically calculate the 3 acres. And then in the post-development condition, those 3 acres are split into 1.5 acres of grass, but then 1.5 acres of new impervious for a total of 3 acres. So all this is calculated, okay? There's some calculations in here which we're not going to do as part of this in terms of calculating the time of concentration values. But the key information is going to be populated in here. So because this is not a tier 1 practice, we're not going to fill anything out in here, okay, for this discharge point. But if you needed to, you can see when you click on one of these cells, there's a drop down and you can select the practice that you have, okay? And then you can enter your TV. And so this TV, this is taken directly from the worksheets that you guys just completed, depending on the type of practice. So this is where that information is going to go. And as we enter this information, these boxes are going to calculate, and they're going to say whether or not we're meeting one of these specific standards. So in this case of the gas station, we don't have a tier 1, so we're actually going to have to continue down to the section starts, I guess, on line 82 right here. So again, these cells have drop downs. So you can see I have a gravel wetland selected, right? And within that box, I have 0.1250 selected. So where does that come from? That comes from the That should be the answer that you received from doing the worksheet for the gravel wetland. So you actually enter that in, 0.125 right there. And it shows up as a tier 2 practice. So then, based on the information that we put in, you can see that we have the water quality standards at met, yes. Okay. So there's some other information on here, which again, it kind of goes beyond the scope of this exercise, but what you would need to do if you were fully permitting this site is you would have to continue down and actually look at the channel protection standard. It is applicable. Is it met with the hydrologic condition method? And it's not, because what that is, that's the way that you use infiltration to comply with that standard. Remember, there's 3 ways to do it. You can use the HCM, or more the traditional extended detention method, or the alternative extended detention method. So we are providing it by 12 hours of extended detention. And we're checking the box right here. You can see some things go away. Gravel wetland, 12 hours detention time. So we're meeting it kind of through an alternate way. So this is going to remain red. And then if we continue down, we're going to look at that overbank flood protection standard. And with that, we're going to say it's yes. Is it met with that HCM method? No, because we're not infiltrating. So what we're doing is we're using gravel wetland. And so then we're looking at these entries right here. And these 3 entries are what we got from the Hydrocad. Remember, we did the Hydrocad exercise, and for discharge point 1, we came up with the fact through modeling that the pre-development discharge is 0.35. And then the post-development discharge before routing is 5.19. But then after we put it through our wetland, we're going to be dropping that peak discharge down to 0.10. So that's how we demonstrate compliance with this standard. Same thing with the extreme protection standard. Pre-development 3.6, 10.15, and then we bring it down to 3.36 after detention through the wetland. Okay, so that's it for SN1. So why don't you guys take the time to go through 2 and 3. I'm going to put handout 12 up so you can see the additional information that you need. And it's 10:22. Let's regroup at maybe 10:40. We can do this by 10:40, and then we can debrief for 10 minutes on that, and then we'll take a 10-minute break, and then we'll just finish out the course starting at 11, if that makes sense. All right, another minute or two here, and we'll regroup and go through the standards compliance workbook. So we don't need that anymore. All right, let's get going again here. So if we could start looking at, I have up right now the, so we're on Discharge Point 2, and we're looking at the Standards and Compliance Workbook. So we have, this is the completed workbook here. So we have the precipitation information filled out, okay? We have the drainage area information filled out. So for drainage area 2, we should have ended up with a total of 18 acres, pre and post, right? So total site area. So we're analyzing the same areas pre and post, but we have in the pre condition 12 acres of woods, 6 acres of meadow, and then in the post condition we have 3 acres of grass, 10 of woods, and 5 acres of new impervious area, right? So it calculates through, and what you should be seeing is you should have entered your tier 1 practices right here, right? So we have the reforestation, the disconnection, and the infiltration basin. So here are these TV values. These should be taken from the worksheets, the individual worksheets that you filled out for step 2. So we plug those in right there. And we end up with the runoff reduction calculations here. So you can see when we plug these values in, we have turned the recharge standard green, water quality, and channel protection green. So that means by the volume reductions alone, by these practices, by these TVs, we're meeting those standards. We're not meeting the standards for the 10 and 100 years. So that means that we're not quite getting enough infiltration to fully meet those detention standards. So we're going to need to look at our pre-post numbers to make sure that we have our peak discharges under control to make sure that we're meeting that. So as we continue down, this is indicating that the standard is met with tier 1 practices for the groundwater recharge. There's nothing entered for the tier 2 and tier 3 water quality because we don't have any. This is saying that the channel protection standard is met with the HCM method. So remember, this is different than when what was in with 1. This is back to 1, where it's saying it's red because we're not meeting it with the HCM. Here we are, so it's green. Okay, so we don't have to worry about saying that we're providing the extended detention, it's just met. And then when we get down to the overbank, this is where we're entering the information about our pre and our post discharge, the fact that we're reducing the pre to post discharge, same with the extreme storm. So then when we go back to the summary tab, this is really where we can look to see under this SN2, we can look to see what we're meeting, right? So for SN2, we're fully green. And you can see in SN1, it's red here for recharge. Well, that's because it's waved, because it's a hotspot, remember? So it's waved. But if we go down through, we can see we're green. It's saying standard applies method with the hydrologic condition method right here. So we're good to go. So this is kind of like the final check of compliance, is this summary tab, right? If we've entered stuff correctly. So then move into 3. The information that you should have entered, we have the woods, 12.4 acres. And then broken down, 6 acres of grass, 6.4 acres of new impervious area. I'm going to go down, so we have the simple disconnection and the bioretention. Is that right? Filter, right. So we're meeting our recharge standard with the runoff reduction, meeting the groundwater recharge right here. The water quality, we're not. So actually this is the good point right here. So you can see where I have within here, within the tier 2 and 3, bioretention not designed to infiltrate. So 0.5317. So remember, on the bioretention worksheet, there were actually 2 numbers that we needed to extract. One number was the water quality volume. So that's where this goes. The reason that we had this smaller volume up here is because the DEC is giving you credit in a case where you have an underdrain. There's a way that you can get credit for the water that is just sitting in the stone by the underdrain. So you can actually get credit for that. It's a very small amount of credit, but that's why this is here. So for that particular worksheet, the filter worksheet, there were those 2 entries that you needed to provide. I realize that's a little confusing, but that's why there's those 2 entries there. So same with this one, we're going to enter, we're not meeting the flood protection standard, the overbank and the extreme by the HCM. We're going to need to put in our pre-post discharges, which we've done. And then we go back to the summary tab right here, and we can look for discharge point 3, meeting recharge, yes. Water quality, yes. Channel protection by the detention method. Overbank, we're meeting it because our pre is into post is being reduced, and same for the extreme right here. So I know that that was quick and that's a complicated worksheet, but hopefully that gives you guys enough background just to understand how it works. And a lot of it is a little bit of trial and error working with it to really figure out exactly how it turns from red to green and such like that, and how you can prove out your compliance. Okay. So I think what we're going to do next is it's 10:46. I think we should reconvene at 10:55. Just take a real quick break, if bathroom break, take a stretch, and then what I want to do is actually jump right into the 3-acre rule, because Wynn is going to have to leave at 11:20, and I realize that there's probably going to be questions on that. And so I want to do that next. And then what we're going to do is just talk a little bit about O&M and some emerging research questions to kind of round out the class. So we'll be done probably around 11:40 and leave a few more minutes for questions. I realize also there's questions, but let's just take a break right now and let's just reconvene at 10:55. And then we can go over some questions and then jump into the 3-acre rule. All right, for those that are back on here, we'll just get started again. There are a number of good questions and answers in the chat. I would just encourage you, I'm not going to take the time to read through them, but there's definitely some good stuff from people and then some responses from Win on a couple key points. So I would take a look at that. I think the one question maybe that didn't get answered, which was an interesting question, is about the, you know, in the case of the 3-acre sites, given that we're looking at existing sites, how would you put in the fact that the impervious isn't changing at all? How would you actually do that in the workbook? And there's actually if you look at the workbook, there's a spot for existing for permit coverage right here, treated to new standards. So you would essentially have your existing under the existing, and then in the proposed scenario, same land uses, but you would have that that impervious under the existing slot right here for permit coverage. So same way when you're, you know, any redevelopment site, if you just think of it as a redevelopment project, I think maybe that's the easiest way. And it's going to be the same thing when filling out the worksheets. When you go through the specific practice worksheets, you have the option to put in if it's redeveloped or new impervious. So you would, you know, in the context of the 3-acre rule, we're working on it's a redevelopment project essentially. So you'd be putting in that impervious acreage as redevelopment. All right, so if we wanted to just jump right into the 3-acre rule, first thing we would want to cover is the engineering feasibility analysis. And we're not going to go into a lot of detail on it, but just to give you the overview of how the 3-acre rule is going to be implemented and how basically we're the process to assess the 3-acre sites. So the engineering feasibility analysis is basically the process that's going to be, that's within the rule to evaluate these regulated 3-acre sites. And the analysis includes maximizing detention, water quality treatment, or infiltration. And essentially there's some get out of jail free cards in terms of your analysis. The state is not going to be requiring purchasing land, changing land use, pumping mechanical or chemical treatment, movement of buildings, destruction of greater than 5,000 square feet of contiguous forest, or offsite treatment.
So just jumping in, the list is actually a little bit more extensive within the 9050 general permit. So you can go there to actually get a feel, but bottom line is like they're not going to ask you to change your operations, you know, in order to facilitate a certain STP, or they're also not going to ask you to break any laws or seek any special permits. So when it comes to respecting wetland buffers and riparian corridors, things of those particular types, those are, as Andres points out, your get out of jail card that basically allows you to, you know, take off of the table certain areas of land, which then is supposed to yield you know, opportunities for some type of STPs to be implemented on the property. So for example, if you've got a parking lot that needs to support your employees, we're not going to ask you to eliminate a parking lot, but if you've got a lawn area that's not being used for anything associated with operations, then that's on the table as being something that could host some type of STP. So you're really looking at this similar to even as the first bullet item indicates, is it's either you're looking at the site to make sure that to identify what the opportunities are, and in this particular case, because you're dealing with a previously developed site, the opportunities are a lot less, but nonetheless our job is to identify where you can be placing STPs, and out of all that use that as the springboard on ultimately determining their feasibility.
Great. The 3-acre site rule. So essentially the general permit 9050, and I know we touched on this a little yesterday, was issued final on September 1st, 2020. And it's going to basically capture previously unpermitted but large development sites with 3 acres or more of impervious surfaces. It will also capture sites with existing permits, which are 3 acres or more, which are not compliant with the 2002 rules. So once those authorizations expire, those existing sites with existing permits will then need to get covered under the 3-9050. And so in the Lake Champlain Basin, I think we're looking at about 700 properties. I pulled this table together from the 9050. Essentially, this is a summary of the timeline of compliance. And so you can see the timeline of compliance varies based on the drainage basin that you're in and also the lake segment that you're in. So just to take a look through these, we have in the Lake Champlain Basin, really the first ones up are going to be the Missisquoi, the Main Lake, Burlington Bay, and Shelburne Bay. And then other Lake Champlain segments are going to be a few months later in June of 2022. And then we have the stormwater impaired watersheds are also on that same timeline. So those are all of the Chittenden County primarily watersheds where there's subject to flow restoration plans, where the timeline there is also first off. And then we get into the Lake Memphremagog, and then after that are going to be all the other sites in the state, which are going to be further down the road. And so my understanding is that at the time the initial NOI is due, there would be a basic information request at that point in time. So basic information would probably mean a calculation of the impervious area, the standard notice of intent. And then once that's actually submitted, there would be 18 months to have the permittee complete this engineering feasibility analysis to determine what is possible on the site. And then after that occurs, there'll be up to 5 years to actually implement the stormwater systems. And so I think a lot of these nitty-gritty details of what that would look at, I would imagine is being worked on and maybe would be produced by, I mean, if it's live December 1st, right, when would you expect some more information later on this year?
Yeah, so like you said, the permit was issued in September 1st, I guess, and it becomes effective December 1st. So we'll have the NOI and the other information up prior to that date, with that date being the deadline of the if not before that date, definitely by that date of December 1st of this year.
Okay. So, what if the site is fully built out or can't meet the standards? A lot of these sites are fully built out and there's a lot of constraints on the site. And so what needs to happen, the DEC is not giving a full pass. You can't just basically pass it up and say, we can't do anything on the site. There has to be some evaluation of what is possible going through the feasibility analysis in the permit. But the DEC, I think, recognizes that, on a lot of these sites, there is a lot of constraints. And so essentially you can, through this engineering feasibility analysis, you're going to say, this is what we can do. And then this is how much left we cannot do on site. And for that portion that's left, the owner will have to pay an impact fee to the state for that remaining impervious surface. And, just to reiterate, the feasibility analysis really requires you to do whatever's possible, and underground systems are on the table. And then for the portion that cannot be met through the justification feasibility analysis, you pay the impact fee. And so just there's a lot of nuances with the technical standards with the EFA, but I think the easiest way to think about it is you need to treat 50% of the first inch of rain in a 24-hour period. So that is, remember, the redevelopment standard. So 100% of the water quality volume is the full water quality volume. That would be like if it was a new impervious surface. If it's redevelopment, you're just subject to treating 50. So what you're able to do is actually, you know, this is looking at the site, breaking it up into two. You could actually treat a full inch for half the site of 1.5 acres of impervious cover, and then not treat the other side. And you can kind of do this, you know, a sliding rule anywhere from 0 to 100. So recognizing that on a lot of these sites, there's a lot of feasibility issues in place, it may not really make sense to be able to collect the entire site and manage 50%. You may be treating 100% of a portion and not treating another, and there is that flexibility in the rule to allow that. So I'm going to go through essentially the impact fee is $25,000 per acre, and it gets pretty complicated in terms of how that calculation is based. But I think just the takeaway is that if you're whatever is left saying, you know, look, we can't feasibly treat this area on site, it's going to be calculated based on the acreage of that leftover area times $25,000. So I think with that, I mean, there are some questions that have popped up, and I think it would just be good to maybe read through these questions and then just use Wynn's remaining time here, about 10 minutes, just to kind of finish off this section. So one question that's come up, will the Connecticut River Basin 3-acre sites have any different calculations to focus on nitrogen instead of phosphorus?
So my understanding as the way the general permit's written, that, you know, it'd still just be the redevelopment standard. There aren't any listed stormwater impaired streams that I'm aware of in the Connecticut River Basin, but they would be held to the channel protection standard. You know, a lot of the primary factors driving this is the Champlain TMDL and the phosphorus goals there. So I don't know if there is a different accounting for how, you know, Vermont's addition of nitrogen to that system and how that's calculated. But the way it's currently written, it would still just be the redevelopment standard in that basin.
And then one other question is regards to fees, only application fees are due with the NOI, no impact fees, correct? I would imagine that.
Yeah, I believe that's correct. So fees, only application fees due with the NOI.
So
Yeah,
the initial NOI, there's going to be no study other than some very basic information on the property. So
right.
we understand what the opportunities are, what the obligations are to pay any type of impact fees will only be determined after the 18-month maximum, 18-month period for preparing the engineering feasibility analysis.
Yeah. Yeah, exactly. And my understanding as well, some of this is still subject to change, I suppose, until the actual effective date. But that initial NOI will just be the administrative fee, not the full review fee that's due with a typical application would be due when the actual the final NOI with the analysis is submitted.
And then if a 3-acre property submits an application for a stormwater permit before 1/1/22, will they be required to meet the 3-acre permit requirements? So if they get an operational permit for a new development, well, then they'll already be meeting they'll be
Yeah.
exceeding those standards to begin with.
Yeah, I guess the only time that would come up is if a 3-acre site were to do new work that needed a permit. And I think in that case, you know, the new work, the expansion area would get a permit as, you know, as any standard project would. And the 3-acre piece, if they chose to handle it at that time, they could, but otherwise I think we would still follow the initial NOI followed by the analysis and application 18 months later.
That actually happened with one of the sites we were working on, a school where there was an expansion being contemplated. So the school was just like 2.9 acres. So with the expansion, they're going to be over 3. So essentially that would trigger, so they would, for the expansion, they would need an operational stormwater permit. So meeting 100% of the manual requirements for that expansion piece, but then they would also need the future 3-acre rule that would kick them into the future 3-acre rule for the existing school.
Right.
So that was one thing. And I guess one other thing to note too is if you're right on the cusp of 3 acres, you can actually remove impervious surface and get out from under the 3-acre rule requirement, right?
Correct.
So impervious surface reduction on some of these sites may make sense that are, you know, close and maybe aren't using all their impervious surface.
So when the state as a courtesy is sending out letters to those properties that have been identified as having 3 acres, but it's still the obligation of the property owner to ensure that if the state thinks it's 2.9 and it's really 3.3, to still come forward and do the right thing.
Right. Yeah, that list is not necessarily exhaustive. It was done on, you know, by a GIS analysis. So there may be sites out there that didn't receive a letter, aren't on the list now, that may in fact be a 3-acre site.
Right. And as far as 3-acre sites and common plan of development, is there any differentiation of the common plan of development rule of thumb?
Yes. So, you know, especially specifically for subdivisions, only those subdivisions that were all previously issued a stormwater permit are brought under the 3-acre requirements. And I believe similarly for industrial parks and things of that nature, if there was a previous permit that brought them all together, stormwater permit specifically,
Okay.
then they would be counted. But it's not just any common plan of development, just without, you know, that didn't previously have a stormwater permit wouldn't be brought under this.
Right, and there are a lot of projects that have or had a state stormwater permit that was issued prior to 2002, and they have
Right.
STP or best management practices. That's what they were called back in the day, and that this whole exercise is basically to bring these properties forward and to eliminate, you know, both the issues of water quality as well as erosion in receiving water, so that, you know, we can basically start to identify at least the biggest contributors to these challenges for the receiving waters as we move forward.
Any other questions that people might have related to the 3-acre rule before Wynn has to head out?
There were 2 questions that came up yesterday that I just had to reference back to the general permit. I didn't have the answers off the bat there. So one was with the half-acre. They're both related to the half-acre requirement. So it does apply to redevelopment as well. Half-acre of redevelopment
Okay.
will fall under that requirement in 2022. And there's a number of bullet points regarding a transition period. So there's a question about if there's a project in planning that's not constructed yet, The way it reads is that if it has all of its required permits prior to that 1/1/2022 date and commences construction within 2 years, it would not require a stormwater permit.
Good, that's helpful. Thank you.
Yeah. All right, well, great. Well, thank you again, Win. I know you got to jump off. Appreciate your time.
Yeah, thank you guys. This is really good. Really well done.
And thank you.
Take care. For the rest of us here, we have really two remaining sections to go through, and I think they're pretty straightforward. Just going to talk about kind of the ongoing permit compliance related to operation and maintenance, and then the inspection protocols with once you get a permit, what you need to do. And then just have a chat about some of the emerging topics that probably are going to be updated in the manual in the near future. And then after that's done, if there's any remaining questions, we can have a little chat, and that'll be it. So I like this little, I don't know where I got this little cartoon, but it's funny with the guy dumping his grass clippings in the in the river. It's amazing how many grass clippings you actually see when you look over the bank. Everybody dumps their grass over the bank, right? I think the biggest thing with the operation and maintenance is these different practices more and more with the variety of practices, especially with the alternative practice acceptance with DEC and some of the filter systems, the subsurface proprietary systems. The maintenance needs are really becoming more specialized with specialized tools, and I think it's always a good idea to be thinking about the maintenance requirements at the design and the permitting level to really understand what is going to be the best STP for the site. And that included with that is who is going to be maintaining it, what the tools are that they have at their disposal to do it, and also the costs, right? So, within these photos here, I mean, just with all these, with the focus on more vegetated systems, I think the maintenance has gone from being strictly really gray, hard maintenance, scooping out sediment, to, landscaping type things, replacing soils and looking at plants and plant root systems and infiltration capability on a filter surface. It's really kind of more evolving to that. And also up at the top here, we have some pervious pavement. And so this is outside the manual, but I've attended some trainings on O&M, and I think it's just worth sharing because I found this to be a really useful way to think about operation and maintenance, is this pyramid system, this tiered system. And I think this is a really good way to think about it, because essentially you do have these different levels of maintenance requirements pretty much on all these sites. They're all different kinds of practices. And kind of at the basic level, you have, the property owners, the property managers, or potentially some municipal staff, kind of like the basic municipal staff without any specialized training. And really that level 1 is really reserved for the basic inspection requirements. And so when you go out to the system every year and you kind of get eyes on it, it's really the basic tasks that somebody without a lot of specialized training or equipment can do. So basically just looking at the system, geez, is the outlet blocked? Is there erosion coming into the inlet? And so, the maintenance plan, which is actually part of the application now, I didn't go through it specifically, but one of those plan sheets that the DEC requires is going to be an operation and maintenance plan describing specifically what the maintenance needs are. Should be developed kind of with this whole thing in mind. So really, if there's an issue at the level 1, kind of annual site inspection, it can be promoted up to more of a trained municipal staff level, and then at the upper level, it could be a qualified professional kind of thing. So, like for an example, you know, if you have an underground chamber and you're looking down into the inspection port and there's sediment in there, but maybe, you know, the operation and maintenance plan says time to clean the sediment chamber when the inspection reveals that there's 50% or more sediment. And so at a level 1, that can be a check that just, you know, your standard property owner or property manager can do. But if they were to find out that, you know, geez, there's sediment that's actually up, you know, 90% of the volume of this, of the structure, and you know, that my maintenance plan is telling me that there needs to be some corrective action, then you're really promoting that to either somebody at the municipal level if they're responsible, or even an outside contractor who could come in and actually clean that out. So it's just some of the take-home considerations. Really, access, you know, is there a need for a right-of-way agreement, and can you actually get to the structure to service it? Again, I think it goes back to whose responsibility it's going to be to do it, and what kind of capabilities do they have, and are the agreements in place at the design and the permitting level to allow them to do it. The cost, functionality is huge. Obviously, snow plowing considerations are huge. And as I'd mentioned, the capabilities of the on-site personnel. So with the inspections, so the way that the permits are issued now is that every permit is going to have an annual inspection requirement, and A&R now has transitioned to an online system. And so the first step is to get an account set up with the A&R online. So you create a user account, and this can be found if you go on, you know, I think if you Google A&R online, this pops right up. It's pretty easy. You just click register, sign in, and essentially once you create an account, you navigate into the DEC Watershed Management Division Stormwater program, and then you're going to have an option to enter the portal for the inspections. And when you first get into there, it's going to ask you to enter your permit number. And so you have to enter this exactly. And if your permit number has a .r or a .t, you actually have to make sure you enter that too, not just the number. But once you actually enter that, the system will immediately recognize that that's a permit that's in the DEC database system. This will become live. You'll be able to click on this, and then you will kind of come into the system. So actually this slide is out of place. This is where you would select, once you go into the DEC Watershed Management Division, here's your option right here. There's a couple other options now for different permits, but if we're just talking about the annual reporting, you click on this. And then once you're in there, it's pretty straightforward. It's basically asking you about ownership, about changes to the impervious surface, and then you get into the maintenance. Really just yes or no questions. When you get down to the end, you can hit certify and submit, and you're done. So it's pretty simple. That's on an annual basis, and there are now also for submitting new permit NOIs and also paying for fees is also able to be done online, which is great. So gone are the days of burning stuff to a CD and putting it in an envelope, mailing it out. So it's nice. No more of that. Anything to add on that, Dave? I'm going to skip down to the future changes and updates here.
Yeah, in the meantime, we have a couple of questions that came in. Lynette asked, when is the manual anticipated to be updated? So that's question number 1 of 2 of hers. Any particular components of the manual that you've heard of that would be updated?
Yeah, so I can answer when, I forget exactly how they left. They definitely had the ability to update the manual regularly on a pretty short timeline. And I don't remember exactly when that is. I guess we're going to have to research that.
Yeah, I know that the way the manual is set up is more for new construction, and they've admitted that there's no way they can create a manual that's big enough to deal with every existing condition situation that's dealing with, you know, the 3-acre rule or the like. So a lot of that is going to be with guidances that are utilized going forward. So that's at least my understanding of where things are right now.
Yeah, I think they have the ability. I know what I'm going to present in this next section is about some of these future changes and updates. And so I know I've been in active discussions with DEC about some of these updates, which are being contemplated right now. And so I know that I'm just trying to remember the frequency. I think it was maybe they have the ability to update every 5 years. I want to say it's 5 years, but I'll have to double check that, where they can actually issue a new manual. And I know it was done that way because they were anticipating the need to, you know, kind of adapt as these additional practices were coming online and recognizing that stormwater is kind of a rapidly evolving field. So they left it the ability to update.
Okay.
Also, Lynette's question about how materials are removed during maintenance and disposed of, and if they need testing. That's a great question, I think. I think that question comes up a lot. And, you know, with, say, sediment in a catch basin, you know, typically that's been done by the municipality, or like a private contractor comes in and vectors out that material that's disposed of in a landfill. I don't believe there's anything specific in terms of the protocols necessary to test that material.
Yeah, when we've asked the DEC, at least the stormwater section, whether those materials are considered to be anything other than benign, they said, nope, you don't have to worry about it. Now, Hugo points out in the next narrative that, you know, depending on what has happened in this contributory watershed that goes into these particular STPs, you know, they could be contaminated. And so I think it really, you just have to be understanding of what has happened in that particular area, and, you know, almost quiz the owner in regards to that. There are going to be times when you can tell outright that there's a problem, but many times you can't. But at this point, the guidance has been that anything in a catch basin is considered to be not contaminated and can be disposed of in any reasonable manner.
So Dave's question, the last question, how is the 3-acre permit requirements going to affect a 3+ acre subdivision with an older permit, no HOA, and no inspections having been done? So I think that gets back to the point of, if that older subdivision, assuming it does not have an existing stormwater permit on it, and the lots are now individual, so that there is not one parcel with 3 acres or more impervious surface on it, I think they could get out from under the permit. Because the trigger is that if that subdivision has an older stormwater permit on it, then essentially that ties them together, and it kind of puts them on the hook for the 3-acre rule. But if not, and assuming there is no single lot that has, and I guess you have to include the roadways too, one single parcel that has 3 acres or more, then maybe they're out from under it.
I think that would be a good one to get clarification from Win on in the future.
Yeah. So kind of to finish this out today, one of the things I had mentioned, you know, some of the changes that the state is considering, and I think the ones that I've been involved with mostly have been related to the soil media changes, and specifically for bioretention and gravel wetlands design. I haven't been involved so much for the bioretention, but I have been involved in the gravel wetlands discussion. And just to give you a little bit of background, stormwater program is I think recognizes that the specs which are in the manual for bioretention and also for gravel wetlands are somewhat deficient in terms of the soil recommendations. And there's been a lot of concern about soils being too rich in phosphorus and actually resulting in leaching of phosphorus out of these systems. There's also been a lot of concern about sourcing proper materials and like what, how media actually impacts the treatment capabilities of this system. And so related to the bioretention, Stephanie Hurley at UVM has been doing a lot of research on that. And essentially it gets a little complicated, but essentially what she's recommended is that really using compost sparingly. Now this is in the context of the bioretention. And so having a maximum of 4 milligrams per kilogram available phosphorus, and that would be tested by this modified Morgan's method. And any compost would not be of an origin of manure or food scraps. It would have to be a leaf litter. And so it would also have to be less than or equal to 3% compost or less than or equal to 5% peat. So this is just one of her findings, and I think one of the things that the stormwater program is currently considering to add to the manual, and really also specifying that you really just need to use compost around the plants just to keep them alive. It's not necessarily for the treatment, and so compost below plant roots is likely to export P. So just a little around the plant roots may be enough, and so that's kind of one of the evolving topics of discussion related to bioretention. And so with the gravel wetlands, if you look at the specifications in the manual, there really is not a whole lot in terms of the soil. The soil is described as needing to be muck with a low conductivity, meaning you don't want the water necessarily go through the muck. The way that gravel wetlands work is the water gets into the gravel below the muck by means of a perforated pipe or some other conduit, stone conduit, but not necessarily, you don't want that water filtering through the muck like you do in a bioretention, where that's actually a filter media. In a gravel wetland, the muck is there just to have the plants grow into that muck and then have the roots grow down into the gravel. So it's a little bit of a different system. So you want that to be kind of a heavier soil with a low conductivity. And one of the things that's being, Eric Roy's lab at UVM is studying this. They're finding that the mucks are more permeable than the spec right here, 0.1 to 0.01 feet per day. So we're getting more water through. So they have they're not as resistant to that water moving through as we think they are. And so this current gravel wetland research, so basically there's a field component and a lab component. And so in the lab component, Eric Roy's lab is actually testing a couple different types of mucks, which are available from local sources: Grow Compost, Green Mountain Compost, AgriSource. And so we have samples, the running column experiments in the lab to really understand how much, number one, how much phosphorus is in the soil, but then is it really a good metric to just have the total phosphorus value? And what he's finding is that it's actually more related to the water extractable phosphorus, and so, which is not necessarily correlated to the total phosphorus. And the water extractable phosphorus value is more important in terms of potentially how phosphorus could be leaching from these materials. And so there just needs to be some clarity in terms of how, the specific test that's done for a spec. Is it going to be a water extractable phosphorus? And then, what test specifically would you use to actually get that get that water extractable phosphorus value? And that's really the questions that are trying to be answered now. The field component, Watershed Consulting is involved in completing that with Sea Grant. We're monitoring 2 different wetlands. One is on Kennedy Drive in South Burlington, and the other one is on Fairview Drive in Essex. And we're monitoring the inflow and outflow from those systems, looking at the hydrology and also looking at phosphorus coming in and coming out and how well these systems are performing. These are both relatively new systems that are both built within the last year and a half. And so this is the first season really that they've been kind of installed and in place. And so I think a lot of the findings of this and also the lab work that Dr. Roy is doing is going to inform DEC about tightening up the specification for the gravel wetlands in the future. So I wouldn't be surprised to see some new information in there in terms of some specific testing requirements for gravel wetlands. This is just, I'm not really going to cover this right now, but it's really just a graphic example of the fact that your water extractable phosphorus can be a really small component of the total phosphorus, and it can also vary pretty widely, and it's not correlated to the total in all cases. So it's a little bit of a tricky, it's a tricky thing to get a handle on. So that is the end of the presentation and the training. And I see there's a couple other questions here maybe we can touch on. Let me just see. Gianna followed up. I don't think this would be the case. Now this is going back to the 3 acres. I don't think this would be the case, but has anyone seen dissolutions of HOAs in response to the 3 acre permit? I haven't personally. Don't know if anybody else has. And then Lynette's question, yes, this is Kennedy Pond 3, if you've been out there. So if you want to go take a look at it, if you know where it is, go take a look at it. Just needs to rain because it hasn't rained at all this summer. So at this point, we were supposed to have many more storms than we've had. We've literally only had a handful of storms that have actually produced any runoff. So it's been a really unique summer for trying to monitor stormwater. Dave, any other thoughts?
No, my brain is still working on the subdivision component. What I heard Wynn say is if it was a component of a subdivision project, that they did get bound together that way. So I think it's one that we can certainly follow up with in regards to clarification on that end of things, because it's going to impact a lot of people. So we want to get the right information out there.
Yep. So if there aren't any more questions, I would just like to personally thank Green Mountain Water Environment for having, putting this on, making the effort, and also for you guys to hang on through this virtual training, which is obviously not ideal. And so I hope, especially today with the live exercise, that wasn't too confusing and that you were able to take some stuff away, because I know it's a little challenging online here to do this in a more of a classroom type setting. So I do appreciate your willingness to stick through it, and I hope you just gained some useful tools moving forward, make this easier. And I'm not sure if Christine is still on or not, but
yes.
If she is.
Yes, I'm here. Thank you. Thank you, Andreas.
Hey, I'm going to hand it back over to you, Christine.
Sounds good. Thank you. Yes, and thank you, Andreas and Dave, for putting this training together. It was really informative. We really appreciate it. Thank you for everybody who was able to join us from the state agency. We appreciate your participation in these events. It's really important to have your presence and involvement. Just a couple of quick housekeeping notes. Again, if you can just sign in, let me know that you're still here. When I say sign in, just put your name into the chat. For some of those who were registered by other members of your team or our manager or somebody else in your organization, I may not have your email address. So please forward that to me so that I can get you your certification of completion for this course directly to you. Otherwise, I will send it to whoever registered you for this course. And if that's fine with you, then that works for me too. If you don't want to put your email in the in the chat for public, then you can send it to me privately. I will get that. Again, and then so for the certifications of course completion, I do expect to have those out probably early next week. I'm getting signatures from the GIMWA president right now on those certifications. I believe that's everything. So again, really appreciate everybody joining us today. You will have a survey attached with your certification. I encourage you to fill it out and give us feedback, both for our presenters today and for GIMWA. So in the future, when we're putting on these types of courses, we can adjust our courses accordingly. We do take that feedback seriously. Again, thank you everyone for your participation, and thank you Andreas and Dave for presenting.